All right, in this video, we'll see the graphs of quadratic functions. So quadratic function generally written as a x squared plus bx plus c. So depending on the value of a, the graphs of quadratic functions can be open up or down. So the first one is if a is greater than 0, then the graph of a quadratic function opens up. For example, if a is positive, the graphs of a quadratic functions looks like either this way, open up, both, or another. For example, you can have a graph like this, parabola opens up, and so on and so forth. For example, for this one, f of x is equal to x squared. The graph of this one looks like this one, opens up. Remember, the value of a is positive, which is greater than 0. The other case is if a is less than 0, then the quadratic equation or function opens upward, downward, here, downward. See, downward. Let's see such a graph. For example, if you have x and y axis, the graph looks like opens down, or it can be any graph of a quadratic function which opens down, or you can add more, this one and this. For example, in order to compare with the first case, you can use this example. Let's say f of x is equal to x squared, negative x squared. The coefficient is, let's say, equal to negative x squared. The graph looks like this one. So these are the properties of a quadratic function depending on the value of a, or the leading term, we call it in polynomial. When you analyze a quadratic function, you have to consider the following information. When you consider the first one, you have to consider x and y intercepts. The second one is, let's check, the second one is vertex. The third one is maximum or minimum values of the quadratic function. The other one is domain and range. I'll elaborate this one, for example, by using a graph. For example, if the graph of a quadratic function is, let's say, this one is not drawn scale, it is a sketch. So, for example, if you extend this one here, and the y-intercept here, this is if you extend this graph down. So this point is known as y-intercept. These points are, these points are x-intercepts, and the maximum point here is known as vertex. Similarly, if the graph opens up, for example, let me draw a sketch of the graph. Let's say the quadratic function looks like this one. All right, let's say this one is these 2 points are known as x-intercepts, as well as it crosses here y-intercept, and this point is the vertex. So when you are dealing with a quadratic function, you need to answer the x and y intercept, the vertex, the maximum or minimum point, the domain, and range. Simply, these 2 pointers, the domain of any quadratic function is a set of all real numbers. So quadratic functions are defined for the set of all real number. However, the range is defined based on maximum or minimum pointers. For example, the range, if a is greater than 0, the graph opens up, and the range is from the vertex point. So the vertex of a quadratic function represented by h and k. For example, vertex depending on the vertex. So vertex is generally vertex. Let's say vertex are h and k. H is a x value of the vertex. So the range, if it is opens up, then it can be written as y greater than or equal to k, or interval notation from inclusive k to positive infinity. Then if a less than 0, the graph opens down, and the range in this case is from negative infinity k inclusive. That means the vertex value of the graph, the y value.